The next topic is single period inventory models. And here we are assuming that the product in question has no future value beyond the current period. So one example is newspaper vendors. Okay, so yesterday's newspaper, you've heard of this adage, so it's of no value. And similarly, there are products that have an expiration date. So beyond that expiration date, then it has no value or maybe reduced value. So the question here is then only how much to order. So since there is no reorder, the product has no future value, we cannot keep it in stock, we have to sell it or dispose it of. So the only relevant question is how much to order. Okay. And the question here is you look at, so what will happen? So you want to look at this as a marginal analysis. So if you want to increase your stock level by 1 unit, right? Okay, what is the expected profit that we are likely to make, and what is the expected loss we are likely to make? So what is the marginal profit and marginal loss? Okay, so that's one thing you have to look at. So marginal profit will be the profit margin. How much is the price that you will be selling the product at, and what is the cost of the product? So the difference then is the value of adding one additional unit to the stock. Okay. The marginal loss is that if you end up not being able to sell that product, then what is the loss? So loss will be the cost of the item that you stocked minus any salvage value that you can salvage. Okay, if the salvage value is 0, then the cost of the item is the loss. So that's your marginal loss. Okay. Now the next question is, what is the probability that you will be able to sell that additional item? Okay. So P is the probability that demand will be greater than or equal to the given supply, meaning that additional unit, or the probability of selling at least one additional unit. That's your P. And so 1 minus P would be the probability of not selling that additional unit. Right? So P is the probability that you will sell that additional unit. So P times the marginal profit is the expected profit. The expected loss is the probability that you will not sell times ML. Now if you set these two equal, or you say that you want the expected profit to be greater than loss, then you can derive the threshold probability. That is, at the minimum, the probability must be this. If you take the terms around and work it out, then this is what will turn out to be. So this is the critical probability, that your probability of selling more than that stock level must be at least that. Then you can add that additional unit, otherwise not. Calculate ML and MP, and then calculate this value and then compare it against the probability distribution. So you need to have a probability distribution. So if the possible demands for the future are discrete, like it can only be 10, 20, 30, 40 or 50 or something like that. So if it is a discrete probability distribution, then you can use the discrete probabilities and then figure out what the optimum stock level should be. But if the future states of nature, the demand possibilities are quite a lot, then you can use normal probability approximation, and for that then you will need to know what the mean of the future the demand is going to be for that single period product, and of course mean and standard deviation. If it is normal distribution, we need mean and standard deviation. But if it is just a few possibilities and you want to use discrete probability distribution, then you need to have the probabilities of each of those demand levels. Okay, so we have the example now. So we have a donut shop, and the cafe buys donuts fresh from bakery, right? And they pay $4 per carton, and they sell it for $6. And if any donuts remain unsold at the end of the day, then they can, so any unsold donuts are just thrown out. So marginal profit is the revenue minus cost is $2. Marginal loss is $4. And let's assume that for this cafe, the number of cartons sold follows this probability distribution. Okay. So these are the possible demand for the donut cartons, and these are the probabilities. Unit cost is $4, revenue is $6, and salvage value is 0. Just throw them away. So marginal profit is revenue minus cost. Marginal loss is cost minus any salvage value. Okay. The critical probability is marginal loss divided by the sum of marginal loss and marginal profit. Okay, so that is the critical probability. Okay, now we have to set up the probabilities. Okay, so we want the demand to be greater than or equal to, so what is the probability that the demand is greater than or equal to 4? So that, if you stock 4, you'll sell out. Okay, if you stock 5, what is the probability you'll sell out? So you want the probability of demand greater than or equal to 5. So you can set this up as sum of, okay, starting from here, going all the way down, okay, and the last one alone, if you make that absolute reference, so then when you copy this formula down, C9 will change to C10, C11, C12, but the ending point will always remain at 15, and that will be the probability. So first time it's the sum of all of it. So demand greater than or equal to 4 is 1, and demand greater than or equal to 5 is the sum of all of those probabilities. Greater than or equal to 6 is sum of these probabilities, and so on. So let's put the thing back. So you want, this is our critical probability. So you want to stop with the stock level at which the probability of demand being more than or equal to that level is at least 67. So here it is good, here it is good, here it is good. Here if you have 7, then the probability falls short of 667. So your optimal stock level is 6, right? So how can we automate this? Here, what is the optimum stock level? Okay. Now we can use two different Excel functions to figure this out, right? So we can use first we need to figure out which row number corresponds with this probability, this cumulative probability is greater than this. So you can see if you do a match, there's a function called match. So match first is the lookup value. So the lookup value is the critical probability. Okay. Then the range that you want to lookup array is that. Okay. Then you have match type. There are 3 different match types. So there is 1, 0, and -1. So if you put 1, okay, it's not going to, it goes over the 0.667. Right? If you put 0, then it gives you an error. If you put -1, then it gives you the row number correctly. And if you look at the help screen for this, you will see what the, so if you look at match function, look at the help for match function, you will see the types. So match finds the largest value that is less than or equal to the lookup value. That's why it went up 1. 0 finds the exact equal, and there is no exact equal there. So -1 is the smallest one that is greater than or equal to, which is what we want. So that gave us the correct lookup value. But what we want is not the row number, but the daily sales. So what we need to do is to enclose this within an index. So if you do an index function, so index function looks at an array like that, right? And then this tells us which row to look at. So index, you have to give two things, row number and the column number. So row number and the column number is 1 because it's the same column, then that gives you the value. So instead of putting index separately, what we do is let's put the index right there. So index of that range, the row number comes from match and column is 1. All right, so there you go. So you can check this out. Suppose if this was 0.9, then it is row 5. If it is 0.4, then it is row 8, and so on. Okay. There is one other thing we can do here, right? So we want to look at which probabilities are included. We can use conditional formatting. So you do it like that. Go to conditional formatting, highlight rules. So here you can say greater than or equal to that cell. And that highlights all the rows that are covered by the critical probability.